Welcome to the information age, aka the modern world. You now electronically submit your exam form? So as the world. You now electronically send your messages? So as the world. And you now electronically pay bills? So as the world. Now, imagine if we are in the same modern world with the same modernized things that we do, except our electronic activities are recorded and stored in papers, like what our ancestors used to do. Okay, now you can stop. Stop. Seriously, stop imagining before we... Oh, there. That just can't happen here. Wanna know why?
Rose Bell, Guel Tamar, Riva Noreen, Nico, on PRIMEadonnas. What the fudge?
The Earth does not rotate backwards. It goes through modernization and technological advancements. Consequently, the information/the data it beholds becomes bigger. It is as well observed to be ever-changing. Hence, the systems being used in handling them must keep up and be constantly upgraded. Years ago, people's data, birth certificates, academic grades, hospital records, and all were manually stored, sorted, and searched for. When things get wet, data's gone until a major breakthrough happened to humanity. A computer was invented. It gave rise to replacements and started to get things done more efficiently. With a few clicks, the world's data is stored, sorted, and searched for electronically. The fun part is, no more coffee-spilled birth certificates, as data could now last an eternity, at least theoretically. A computer is like a device that has its own brain. However, it is not a brain that's behind it. What makes a computer run is none other than the binary code. Let me tell you how it works. Binary codes are a series of ones and zeros that usually represent true or false, and yes or no. It has played an important part in data sortation and management, even before the information age/the computer era. They have used edge-notch cards and punch cards in the past. Edge-notch cards, or most popularly known as McBee cards, works quite literally. They are cards that have notches on the edge. You use it by sticking a needle through the hole. If the card stays, it means 1, true, or yes. And if it falls, it means otherwise. Then, in the earlier stages of the computer era, punch cards were used to input data on a computer through binary codes, but in this case, it's either holes or no holes. Today, computers still use binary codes, but instead of cards, we now use microtransistors. Microtransistors are microscopic switches that are either turned on or off. One transistor is called a bit, and a row of 8 transistors is called a byte. Here's how the computer reads those data. If all the bits on a byte are turned on, it adds up to 255. That is the number of codes available through ASCII, or the American Standard Code for Information Interchange. There is an ASCII code for each upper and lowercase letter and for every symbol as well. Example, for the capital letter A, the ASCII code is 65, which in binary is translated to 0, 1, 0, 0, 0, 0, 0, 1. So whenever that character is typed in a computer, the first and the 7th bit of a byte somewhere inside the computer is lit. This is the list of printable ASCII codes. Now pause the video and try converting your name from letters into ASCII codes then to binary code. The binary system can also be used in search algorithms. Again, 1 if the statement is true, 0 if false. However, this type of data search algorithm only works when the data has numerical value and can be arranged in ascending order. This is how you do it. For example, we're looking for the number 69 on a set of numbers. The number that we're looking for is called the search element. Here's the index, a numerical value assigned to each element of the data set. First step is to compare the search element to the median. If it doesn't match, we are going to divide the data set into two. If the median is greater than the search element, we go to the left. If it's less than the search element, we're going to the right. In this case, we're going right. Again, we're going to compare the search element to the median. Since the sublist has an even number of elements, the median can be either of the two elements in the middle of the sublist. And since the median is not equal to but is greater than the search element, we move to the left. Search element 69 is compared to the median of the list. Now the values match, therefore, the result is found at index number 6. And furthermore, this is how the code for the binary search algorithm looks like on the C programming language. And that's why we stopped storing and sorting data on papers. The modernized data in the information age requires modernized handling. We also have established that we got it easy these days because of the contribution of the binary code on data sortation upgrades. If it was possible in the past, soon the binary code might again lead to a major breakthrough in data sortation.